Welcome back to another episode of Out of the Blank Podcast. Andrea, it's a pleasure to have you back on the show. I'm not going to act like we didn't just talk for a little bit off air, but how's it been? It's been a very long time.
Very long time. I think it was just a few months ago, right? Thank you for having me back on the show. It's been okay. Trying to discover the mysteries of the universe. Haven't discovered yet what dark matter is. I think we talked about dark matter last time, but we're getting some interesting results. Um,
When you say interesting results, are we able to find enough evidence on what it is yet?
um, yeah, well, I think we just find out that what it cannot be. So I think that's already enough clues of what we can do in the future. So I think one of the main theories for dark matter was like this idea that the dark matter is a very massive particle, um, which moves very slowly. So there's a category out there called the cold dark matter models. And we've been looking for this for many years. We haven't actually been able to detect it either in space or in the lab. So I think we're fairly, I mean, we haven't been ready yet to toss out the theory altogether, but obviously people are looking at alternatives to cold dark matter. And so I think one of the interesting models that we looked lately was warm dark matter, so slightly lighter particle.
That's
Yeah,
exactly what we
so
were talking off air. I was trying to figure out what the answer was. It was cold dark matter. I saw a term be labeled for it, and then another one was warm dark matter. So, I mean, it's out of the hypothetical realm, even though we don't have evidence of it. It's not in the category of hypothetical, which if you ever brought it up and said, someone asked you to show it or explain it, you'd be like, well, I can't explain it. Then people say then it doesn't exist. But that's not that like that with the conversation of dark matter.
well, there's still people out there who says that they don't exist and they're genuine scientists. So there's another model out there that says, well, we might not understand very well the force of gravity. So there's a theory called MOND, which stands for Modified Newtonian Dynamics, which basically says, well, if you take Newton's force, you could just play around with it and just change a bit the power law, so that it stays the same here on the Earth or nearby, where we can actually measure for very precisely. But if we go out there in the universe, it might change a bit. So at a far distances, if you change a bit this power law to adopt a slightly different force, then you modify the dynamics of and basically modify the motion of stars and any objects in the universe. So it actually needs to invoke dark matter per se, but obviously a lot of people are fairly convinced that there should be some sort of matter out there which has no connection with normal matter, and it's just a matter of time of finding it, what it is.
Now, is it all around us? I've heard that get tossed out a couple of times from a few conversations. I don't remember if you mentioned it to me in our first episode, but if it's all around us, then it's just about activating it or trying to find a way that we can actually perceive it. Which, like I said, I was talking to you off air about the podcast I was listening to with Neil deGrasse Tyson. He was talking about things that me and you and Haystack had talked about, where he showed a graph of all this noise in the beginning when the Big Bang happened, and then how it's kind of slowly faded, and you start to see like the universe get created and a bunch of things get created that UV light aspect of things. I was like, we know about dog whistles, things we can't hear on a certain frequency. We know about things that we can't really perceive on a certain frequency either, whether it's with our vision. So I go, if it's about trying to find those particles and if they are all around us, then what would make those things tick? And that would be trying to find matter that could interact with it, that could change. I wouldn't say the consistency of it because that's a bad word for it, but just be able to change it enough to where you can perceive it. I think it's at a frequency where we can't perceive it at all.
Yeah, well, there's a lot of things we can't see around us, and like for example, we only see in the visual part of the spectrum, right? So there's a lot of stuff that there's a lot of part of the radiation around us that we can actually see. But if we build telescopes in or instruments in other part of the spectrum, like for example, there's stars out there who emit more in infrared or UV or X-rays and so on. So you suddenly can see them. There's some observations of gravitational waves, which are not part of the normal part of the spectrum. So we can also detect the gravitational waves in the universe from merging of black holes and stuff like that. Um, yeah, so the idea was that, okay, well, maybe it's, we don't have the right type of observations. Obviously, the problem with dark matter, it's dark. that hints the name. It basically doesn't emit in any part of the spectrum. So it doesn't emit in the visible, doesn't emit in infrared, doesn't emit in X-ray, doesn't emit in UV, and so there's basically you're out of any options of like detecting a normal part of the spectrum. So I think most of the, like I'm an astrophysicist, so most of the time that astrophysicists trying to detect dark matter is just by finding how it affects the visible matter, because you can actually see the stars, so you can see the motions of stars. So if these motions are a bit off kilter, then you could say, okay, well, why is this star acting so weird? Maybe it's something near it that it affects its orbit. So yeah, it's everywhere near us. We actually know, we have constraints about how much dark matter is in the universe from that map that Haystack was showing, which I presume is like this cosmic microwave background, something like that. Sounds familiar. It's basically just an image of the early universe that we see. There was a Big Bang, and there was like a lot of radiation left over from the Big Bang. So this is basically as the universe.
I'm
Allegedly,
kidding.
yes. Yeah, so this basically, this leftover radiation from the Big Bang is what we actually see, and this is also all around us, and it's fairly homogeneous, but there's tiny variations in this image, like little bumps up and down, and from this, like from the there's basically some polka dots on the map, so just measuring how many they are and what the size and so on, you can just like find out how much matter is there in the universe. So basically, there's way more matter than all the matter that we see in stars and galaxies and so on. So we can have a very good constraint of the amount of dark matter that was basically just created, if not at Big Bang, very soon after. So it should be around us. The thing with dark matter is because it only feels the force of gravity, it attracts other dark matter. So it doesn't stay smooth. If you just have a tiny bit of seed of dark matter, it just attracts more dark matter. So you can form clumps of the size of stars, or even you could have like clumps of the stars of the Earth. So you have like a little clump of dark matter just the size of the Earth. And obviously stars or galaxies and so on, it could go on very large masses because it only attracts other dark matter. So imagine this universe is basically filled with like a smooth dark matter, but also like all these clumps of different sizes from small to very big. In terms of like how much dark matter is in the solar system, hopefully there's no big clumps bumping into us, but should be like a fairly smooth distribution of dark matter all around us. So we in principle could detect it either directly if we know how to do it, but most of the experiments, as I said, they're basically indirect detection to see what does this dark matter does to objects that we can measure. I don't think there's too many experiments in the solar system in terms of astrophysics, but well, it depends on what it does. It could affect other objects, but it could also interact with itself. Again, that's not 100% sure, but there's one of the models. So for example, you get two dark matter particles colliding with each other, and they could in principle disappear and just like emit normal radiation. And that would mostly be in the very high energy part of the spectrum, the gamma rays. So if you have a gamma ray detector, you could see this glow in high energy radiation. But this glow doesn't come from any stars or anything that so must come from dark matter. Now we haven't detected that yet, so that's kind of what people are trying to do with dark matter.
What's interesting to me is that you're saying through X-rays, through spectrometers, through a bunch of different things, we're not able to measure dark matter. That means it's on a frequency that we have no technology to be able to find yet. And this is kind of what sparked up my interest in space again, which is the discussion about black holes, where I think people hear black holes, it sucks up everything. And it's like, oh yeah, it's cool. I was like, well, say that again. That means sound. That means like anything you can possibly think of, it gets basically neutralized. We don't know where it goes, but we can't perceive it anymore once it enters the black hole, whether it gets stretched out and expanded all around. And to me, that just like I got goosebumps over just like thinking about that a little bit more. Now, if we talk about dark matter, if it's all around us, but we can't perceive it, and we have no technology on our scale to be able to go from 0 to 10, you can't find it anywhere with any of the devices we have, which makes me ask bigger questions, which is we don't have anything. I would say like we have gas detectors. We don't have anything that could be able to pick up at any frequency of what that is. So I'm wondering Do you think that would impact cells? Like if we talk about smooth area where dark matter is, if it's smooth all around us, but then there's these clumps, is there a significant change that people can perceive? Now, I'm not saying that people's intuition is better than technology. I'm not saying that at all. But what I am saying is like obviously there's people that are sensitive to certain things, whether it's like technology as well too, certain frequencies that computers can give off, cell phones can give off. People feel like they can get affected by it. Whether that's true or not, I don't know. But the person who usually is shouting it from a rooftop with a tinfoil hat on their head is typically, not the type of person I want to mess with. But when it enters where people can perceive it, or if there is a way to be able to pick up what that is, whether it's in a certain area that has a lot of clumps, or if it's a certain part where it's smooth. I'm just curious. I mean, do we have anything? Have we torched the fields in the essence of trying to find research ways of being able to detect it? Whether it's with some of the fringest ideas out there, I would feel like at this point trying to just understand or be able to pick up its existence because it's not in the Russell teapot discussion. It's not like saying just because I tell you there's a teapot floating in outer space, you can't prove me wrong or can't prove me right. It's not that discussion. There is a large amount of people that do believe, and I believe it as well too, that dark matter exists. Now it's about trying to make sure we can perceive it. And I'm just wondering if we've tried any fringe ideas out there besides doing something that's very scary, which is like trying to manipulate certain things that might be really kind of experimental that could actually cause more damage, such as like ripping apart something or doing something like the Hadron Collider. There's a lot of theories of people saying it was going to cause like a black hole or something like that. But I'm just saying, is there anything fringe idea wise that people have tried to experiment, at least tossed out, that we haven't just gotten there yet?
Well, I would say all ideas are a bit weird, obviously, because we don't haven't detected dark matter, so we don't know, we haven't actually detected. So I think all ideas are worth investigating. Um, I think the techniques are fairly standard. You basically measure what you can measure with when like motions of stars or any type of radiation, and just work backwards where they might be. You have to obviously know the signal, as you said, what the luminous matter does. So, for example, you have to know how a star would normally move around. Let's say if you have a galaxy, right, a spiral disk, and the stars moving all around. Um, if you just have stars, you can just compute how fast the star would rotate around the galaxy. But if you throw in some dark matter out there, obviously the stars would pick up some velocity. It's like in a merry-go-round, right? So you just put more push into the motions of stars. So basically, just finding out how fast the stars go, you can find out how much dark matter is out there. Um, so I think I wouldn't say that's fringe, but obviously people, there's like dozens or so different ideas of how to measure dark matter. Dark matter could also affect not just galaxies, but like bigger structures in the universe. Like you have when galaxies come together, they form a cluster, so that there's more dark matter out there. Dark matter, as I said, could be at the size of the solar system, and so I think these kind of experiments or these kind of ideas are a bit more harder to test. What dark matter would do around the solar system. I think I probably mentioned the last time there was this idea that actually dark matter might have had an effect on the solar system. If that the edge of the solar system, there's this asteroid belt, and then if you pile up a lot of dark matter out there, would just throw it in some of these asteroids to Earth. So there was some idea a few years back saying that maybe what killed the dinosaur was one of these asteroids that was just pushed from the asteroid belt by dark matter. But I think that idea, so maybe that would be a bit more fringe, but I obviously it's a genuine theoretical idea. The thing is that you can't actually test it, right? So if you don't test it, it's a nice idea. And so in principle, people are trying to put out ideas that could be tested.
Now, is this might be pulling, I guess, over analyzing something a little bit more, but if from our discussion, we mentioned that dark matter, the universe is made up all of dark matter. It's just all around us. So if you get to the point where you look at before planets or before, what we are living on now was fully created. So you look at this even before the human species was created. Did we adapt, our cells adapt to not be able to perceive dark matter? Or is it just at a low enough frequency to where our bodies just don't perceive it at all and it doesn't even really enter the status of reality? We know it exists, but it's just the perception of reality. It just doesn't hit that layer. I mean, what's more I would say, fringe as an idea that our bodies had adapted to or even the planet had adapted to not perceive dark matter because it's just so, I guess, a low light, like a dimmer on a burner or something? Or is it the factor of it's just not being able to be picked up by reality because of the light being so dim?
Yeah,
I'm trying to understand it as much as I
yeah,
can, but it's
yeah.
complicated.
We did adapt in a sense that we basically the product of how much dark matter is in the universe. As I said, the dark matter basically attracts. It just feels the force of gravity, so it attracts other dark matter. If you put a lot of dark matter, so at the moment, the measurements of how much dark matter is basically have 8% from all the matter in the universe, about 85% is dark matter, 50% is normal matter. But let's say you put way more dark matter in the universe, right? So you just make the universe very heavy with this unseen matter. The dark matter, because there's more dark matter, the clumps will grow faster. So you have like big clumps of, so the galaxies will grow faster, right? And maybe that has an effect on how you end up with life in the universe, because if everything grows very fast, you basically need a lot of time to form life. um, the life, I think the Earth is like 4.5 billion years, right? So you kind of need at least 4.5. Well, you need a few billion years to form an Earth, kind of like a planet around the solar system, and then you need to give a few 100 million years or so on to start life and so on. So to evolve, beings like us with consciousness probably need a bit more time. So you need some time, right? So if you put a lot of dark matter in the universe, the universe could even collapse. So we know, if, for example, right now we know that our universe is expanding, but if you put a lot of dark matter, the universe will just slow down and just fall onto itself. We had a big bang, we might have a big crunch. Right. So the universe could basically just implode into a point. And that's what happens. So I think in the end, the fact that we are here to observe the universe is basically also a product of how much dark matter is out there. So maybe in that way we adapted. Now, obviously, dark matter is not that important for life. Otherwise, we would have adapted to it if it would made any sense to kind of would be any useful for creating life. There would be either we would interact with dark matter, or there would be dark matter beings, dark matter planets and dark matter solar systems and so on. The thing with dark matter is a lot of it, but it's very interacts very slowly, you know. And so because it's very diffuse, so you can actually form anything like, an object made of dark matter. The biggest objects the smallest actually objects we think that matter can make is like the size of Mars or Earth, things like that. And not even those objects might not survive all the time because they get ripped apart.
Small, that's not small at all.
Yeah. I mean, it's possible that one of these little clumps could be hovering around or just being around the solar system, right? So
I
might
would
might have some effect.
I would just think that it would be kind of like, if you ever, I don't know if you've ever seen gas, like when it comes out of something, like whether you're pumping up your car or something like that, there's like a weird rift. I wouldn't say a rift, but there's like you see the fumes of the gas. It just looks like your vision trying to look straight looks like everything's kind of moved to the side a little bit and then it corrects right back. And you realize that that's just you're seeing the gas fumes come out. I would think if you had a giant clump of dark matter or something like that that clumps up in one huge spot, whether it's in space and it's just like the size of a planet or something, but you can't, there's nothing there, but it's all clumped up together that we can't perceive, that it would cause it to create not really a rift, but it would cause it to create some type of abnormality in our vision that would pick it up. Like, why does that seem like it's not 100% straight? Which I'm not just bringing it to certain examples of abnormalities that we can see all the time with our vision and other things as well too, but it makes me think a little bit more, which is like there are some things that haven't been really explained in certain instances when it comes to just something our eyes do, hallucination, something of that sort, where I start going, is that just a certain area where there's a lot of noise of something? I'm not necessarily blaming it all on dark matter or saying it is dark matter, but I mean, would it be fringe or crazy to say that is it possible that there could be some type of thing going on? And I know there's explanations for hallucinations, like mirages and stuff like that. But I also go, there's certain instances that don't fit under the qualifications of a mirage that are out there. and we just can't explain what those is. Whether it's technology that goes haywire as well too, where random things, and you can call it electromagnetic interference or something like that. But there's some things that don't fall under those certain categories that get chalked up into, random occurrence or something like that. And I start going, could that be a possibility? Much like if we have a bunch of clumps in space, could it be something like that where there is a star there, but you can't see the light from it because there is something that's going on that's causing it to look like it's going in the complete opposite direction? I would chalk it up to space madness or something where it's like, yeah, we went on the wrong information. It was because there was this thing where actually we calculated wrong and it's actually in the spot we thought it was before, but we made the adjustments because we were actually going off of something that was actually misperceiving us.
Yeah, there's actually a technique based on this. It's not really a mirage because once you understand, it's not an illusion anymore. So basically, like you say, if you have like one of these dark objects, could be a dark matter clump, or could be a black hole, or it could be anything like a very faint star just moving in front of other star. It just diverts a bit the light, or it just dims it. So it makes this like the light from a star doesn't look like it should be. So this could actually be observed. This is how, in fact, how we actually observe or how measure how much dark matter clumps are in there, or how many the black holes are out there in the universe. So I don't think that this effects are also observable on the scale of the Earth. It wouldn't make too much, because the clumps, you need basically smaller clumps, because our vision, basically we have objects of finite size, a few 100 meters or so on a few kilometers, right? So you probably need a clump of that size to kind of have an effect. But yeah, so there's a whole range of techniques out there to just measure these distortions in the light of objects in the universe. It's called gravitational lensing. So it's basically having a lens in front of you, and then you can create all kinds of like distortions. And the gravity from the dark matter or a black hole or anything that's dark basically distorts the light. So you can see, for example, distorted images of galaxies, or you can see a light that should be like a point in space is basically distorted into an arc. It's called gravitational arcs or lenses. So anyway, we can see that all the time. We see all the in fact, everything, a lot of images in the universe are distorted. And this is in fact how we actually put that constraints on how much dark matter is in the universe using this technique.
So when you say a lot of images are distorted, does that bring up the area with conspiracy theories where like a lot of people think like they're lying to us? I just that's immediately what I thought when you said that. It's like when you talk about distorted images, are we talking about like actual pictures of things that we take out in space, but because there are certain things that just mess up technology that it ends up the message gets mixed up or something like that?
Yeah. I mean, you see that all the time. I would say most of the images in the faraway universe are a bit distorted, especially if you get images of objects in the center of galaxies or in the center of clusters of galaxies. It's like, again, you can see, you basically distort, depends on the geometry of the lens. You could have, like you go into the amusement park, so you can make yourself like bigger, longer, shorter, rounder, things like that. So we could see images of galaxies or stars, which are distorted. And because we know the geometry of we've done optics, and this is just like another lens. It's just powered by gravity rather than visible light. So it's a gravitational lens, but the physics of a gravitational lens is very similar to normal optics. So we can see distorted images, so we can basically reconstruct it, find out where the dark matter is that's doing this distortion, how much it is, and so on. So we have this huge 3D maps of dark matter in a universe just using these techniques of distortion of light from galaxies. So there's depending on, there's strong gravitational lensing if you have a galaxy like light in a very big center of a cluster of galaxy, but you can also have also called weak gravitational lensing. So all this dark matter that's spread all around the universe. It's basically like when you're at the pool and you see you're at the bottom of the pool and you see this light, you see the waves at the bottom of it's the same thing. You see the light broken up from different galaxies, but in a much more like diffuse way. This is called a weak gravitational lensing. And basically look at the shapes of galaxies. They're all kind of distorted. And it's a new telescope coming up, being launched in space in July. It's called Euclid. It's going to look at all these images of galaxies, like billions of galaxies, and from the distortion of these images, you just constrain dark matter, but also dark energy, another dark thing that's out there, but which is not no matter, but we don't actually know what it is. It's some sort of energy that, again, we can't see.
Is it does it have any usages of it? Like, how do we get the classification for understanding what dark matter can do property wise? If we could talk about not perceiving it, but also I mean, like I said, I'm sure we'll get to this somewhere in the discussion, but also the evaporating or just expanding out particles. Like I said, I went down the rabbit hole of the weapons and using dark matter as weapons, and that was like a major thing it was talking about, which was that it could just take atoms and spread them either extend. I don't know what the word would be to use them, but it just expand them out. So I'm just curious, like, how do we know that that dark matter could be used for that certain purpose? If we haven't been able to really, we know that it exists, but being able to pick it up, like, how do we start giving it properties? And then I bring in the question, what do we define what the space is? Like, are we just talking about space, defining it as the things that we can see that have lights and stars in it? What about if it's ever expanding? We haven't been to the edge. So does it just keep going? And do we call, if it's just all black and you're just going in one direction? That's still space, in my opinion. So it just doesn't have any noise out there, or light hasn't been out there yet, or anything hasn't been created out there yet. But if you can keep going, then it has to be something else out there, right? It's like going on a road with no headlights. You're just driving, but if I'm still moving, then something exists.
Yeah, dark matter weapons is the first time I hear about it. Is it like a thing? Do people talk about this?
I found a couple of good articles on it, and then there was a government article on it as well too, which was like the idea of the possibility. So I was like, I didn't know, I've never heard of it before. I didn't know we could even, I don't know if it's sci-fi
I don't know.
era.
Your government doing crazy stuff. I hope we never have a dark matter weapon, but
That's how we get funding, to be honest with you. I mean, that's always the military that has to throw something out there. And with the UAP discussion that got brought into the mix on the government side of things, I just don't toss it out. I mean, I would like to see more funding get pushed because I feel like with academics, you guys are usually fighting for a lot of funding on some certain instances as well too, and then either having to prove your case on certain research that you're doing. And I just go, I mean, guys should be able to not have research that's influenced by certain studies either. Like research integrity is a big thing area that I'm interested in. But also, I mean, we have plenty of money that gets tossed out to the military every single year. You can toss some out to some academics or some institutions to be able to research into some interesting things as well too. But it becomes in one of those discussions where it's like, what does it benefit us if we research into it? And it's like, well, I mean, the benefit of understanding if there's life out there in the universe seems to be the discussion that needs to be had now. And then it's also when you talk about like a topic, I mean, what stops dark matter from being a fringe theory and pushing it into the philosophy area? But I think that's just because the understanding of space, it's so vast where the public goes, you can really say anything to the public and they would kind of accept it because they're just not, I wouldn't say good education on it, but there's just not a whole lot of connection when it comes to people's understanding of certain things like dark matter, certain things like black hole. I'm not saying you, I'm just saying for the general public, that's not the person who goes to a construction job or anything knows anything about dark matter or any instances of that sort. And I don't think that's or not lack of trying. I just think that there's obviously celebrities and other things out there that are more interesting somehow for our public consciousness to get hooked to than it is to be able to talk about certain instances. Like I think Neil deGrasse Tyson does a great service when he goes and speaks about these types of things because he puts it in a platform that can be able to be understood and get the public really interested. Like your example with the pool example, that cleared it up for me right there. I mean, I understood that completely. And I think that's what the message has to be relayed to as well, too, but also giving it prime air to be able to talk about these types of things too. It doesn't have to just be whenever a giant event happens. Like, oh, there's this star that's gonna like the I won't say it's an asteroid, but Oumuamua. When that came by, a lot of people started caring about space a little bit more because like, holy crap, what is this? But it got chalked into the extraterrestrial civilization messageable thing when I had Avi Loeb on here to talk about it. And I don't think you necessarily need that to get the public interested into it. I think you just got to explain, like, there's a lot of things out there that we can explain, and we could easily try and find ways to be able to explain it, but also sparking up the interest. And I think once you get the public on board, your work will probably be a little bit easier when it comes to just being able to research and have the money to be able to fund your research.
Yeah, well, there is a bit of an embarrassment that we haven't actually found dark matter in at least 70 years. And there's actually even ideas before that. People were talking about dark stars and things like that. There were actually some predictions that there should be some dark objects that trap light around them. But yeah, I mean, there's like thousands of people working on detecting dark matter, both in astrophysics and in particle physics. So it is a bit of a problem that we haven't detected yet. Why is it important? Obviously, besides the things you mentioned, that we just need to understand our place in the universe and all that, it's also good to just do research. You don't have to have an immediate practical use of it, like a weapon or anything. I mean, for example, in principle, dark matter might have its own use in, I don't know, 100 years or so if we detect it. Like, for example, electricity, right? The electron, that's one of the examples that is used a lot of times when scientists are asked to kind of give a reason why they're doing fundamental research. Like, when the electron was discovered, it wasn't necessarily clear all of a sudden that we're going to have electricity and we're going to power everything. Your computer is powered by electricity and so on. A lot of research in the beginning was done just from a pure theory's sake, just to understand what this little particle is and what it does and so on. So I think we're at that stage now with dark matter. We just want to know what it is. It's also interesting that most of the universe is made of dark matter and not like stuff that we are made of. Yeah, I mean, it's interesting that you mentioned Avi Loeb, because he actually uses this type of argument to, I think he had like a little speech there saying that, well, we spent $2 billion and so on finding dark matter, and
I know he
it's
yelled at
just a
me.
failed theory. Instead, if you can just put a few $1 million to find things like Oumuamua. I'm not saying that's not worth also obviously it's worthwhile, but I don't think this could be one way or the other, right? You could just do both. And yeah, it was a bit of a surprising argument coming from him because he also studied dark matter. So it wasn't, so I don't think the public needs that kind of argument that, pick your favorite scientist or your favorite scientist, let the people do their science. I think obviously people have to justify why they're spending, and obviously scientists want to find out what dark matter is as well, because they're spending most of their lives trying to understand it. They wouldn't study if it wasn't worthwhile, at least to them.
Well, it's something when I brought up to him when I spoke with him, he got kind of mad at me about it, which I told him just to put a little bit of the alien talk on the back burner for a little bit and kind of look at more of the science angle of things. But I started to realize kind of why he was hitting the alien subject so hard with it, which is not only because he's part of the Galileo project, which has like a mix of combinations of people that like Massimo Teodorani's on there. I've spoken to him multiple times. But it was more about the alien was in the public's perception. The UFO subject was in the public's perception. If that's a great way to get the public on board and get your funding as well, too. I just wish you guys didn't have to, him in particular, didn't have to sales pitch it like that. Now, does he believe aliens? Yes, 100% he believes that was an extraterrestrial thing. But it's also about like the science should be just as interesting. And I mean, it's not an embarrassing thing for you guys who study dark matter to say that you haven't been able to find any evidence of it. You're trying to perceive something that isn't perceivable, which is, I think, why a lot of people still, it's interesting to them because there is that. It's much like saying like the whole God discussion. I mean, there's people that believe in God, even though you can't see God, but then you say God's all around us. Well, so is dark matter. So then if you really could enter the discussion of like, there are things out there that we have been known to prove that actually does exist, but for the longest time, we never had the technology to understand what that is yet. And there's always new things being discovered all the time. The only thing that got a bad rep was Pluto, because Pluto's not a planet anymore. Technology did not help out that case at all. But when it comes into understanding something that you can't perceive, I think the interest is always going to be there. But I, I just don't know how long, if you understand like the institutional mindset of wanting to discover it more. But I think we have enough evidence to keep it going for a while. I think it doesn't enter the concept, like I said, of Russell's teapot, where it becomes a hypothetical argument. It now just becomes to the point of when are we going to have the technology to be able to perceive this? Because we do believe that it is a constitution of what created after the Big Bang, what created the universe, which that is one of the biggest interesting mysteries, which is how do we get all this type of stuff that goes on in our universe? And it just keeps on growing and growing and growing. Now, if there's a hypothetical fringe argument of stars being able to somehow interact with dark matter, why can't we?
Well, obviously we interact all the time with dark matter because, you know,
But I can't
dark
play
matter
pickleball
is
with it. I can't play pickleball with
no, you can't actually, unfortunately. So I think there was a type of someone calculated how much dark matter goes through us every second is like something like huge amount, like I don't know, a billion particles or something. I don't know if maybe I'm getting the number wrong, but
Good. Tell
anyway,
me
like
that.
a huge amount.
I'm gonna call out
Is
of work now.
basically you're just flooded with these dark matter particles that just go past through you, but there's no so there's lots of dark matter around us or through us, but it doesn't do anything. So it doesn't interact with, because if you would interact with a cell or with anything, it would give a little bit of signal that we can in principle amplify, right? If it's a little bit of like, let's say, a current, you just have this, we have this technology that if there's a tiny bit of electric current out there, we can just amplify and see it, measure it. If it's a little bit of electromagnetic field, we can also measure it. If it's anything, right? Any type of force or any other. So there's four forces, right? There's electromagnetic, gravity, and stronger nuclear force, right? If you interact with a nucleus, would also be able to detect it because we have these big accelerators. So unfortunately, it doesn't interact with anything other than just gravity. And even though there's like billions of particles, the force of gravity is much, much weaker than anything else. It's like 40 orders of magnitude, 40 times, no, 10 to the power of 40. So a lot weaker than any other forces, right? So the things that bind our body together, like the cells and everything, are bound by electromagnetic force, which are much stronger forces than the force of gravity. So even though there's a lot of dark matter out there, it just interacts very weakly via gravity with us, and we don't actually detect that. Now, if there is we do detect gravitational waves. Again, that comes back to your question about the space, right? Space is just like space is actually space-time. It's like a fabric of both space and time, and it's literally like a surface, right? We could vibrate, could have like distortions in space-times as well. So in principle, we could detect gravitational waves. Again, that would be if we get a gravitational wave hitting the Earth, it would be like a little bit of earthquake, right? It would just you could actually measure that. We do detect gravitational waves from merging of black holes and stuff like that, but not yet from dark matter. So, yeah, I'm not sure if that answers your questions. We basically just restrict it to one way a type of measurement, which is force of gravity, and it doesn't do anything on our scale because just not enough. The signal is not strong enough. But the only way we can measure, and in fact, the signal is very strong, the big scales, like the way it affects the entire galaxy or a cluster of galaxies or entire universe and so on like that. Yeah.
Do we know, like, if black holes, or the article that I read talking about supermassive black holes, I don't know if it was that or primordial black holes, could be one of the things that are expanding the universe? Does that mean that there's a similar connection between that and dark matter as well too? Like, is there a way to be able to? I know we talk about putting another black hole into another black hole, and I know it goes down the concept of wormholes as well too. I've heard that argument get tossed out there, which is like, I think I'm interested in it. I'm more interested in the multiverse theory, to be 100% honest with you, because I would like to meet another me and just be like, tell me you're more successful. That's it. That's all I want to know. But no, when it comes to dark matter and the connection with black holes, I mean, is it possible that we could use something with black holes, either a type of frequency or anything? I mean, have we been able to find what interacts with them? I know everything, it gets sucked up into them, but we talk about radiation and gravitational waves and things of certain sorts. I just wonder, do we have concepts of things that we can look at, like a black hole, find what disrupts it or does something to it besides just tossing another black hole into it and then watching it get sucked up? But is there a way to have a type of manipulate the properties of a black hole, which I know is again fringe science, but I would like to know what the fringe idea would be to see if there's any type of connection to be able to pull out a reaction from dark matter. Because I would think if dark matter is all around, it still gets sucked up into a black hole, from what I understand the properties of a black hole.
Yeah. Well, not everything gets sucked into a black hole. It's basically a black hole acts like anything, like a star. Like the sun doesn't suck up the Earth, right? The Earth, it just orbits around the sun. Now, obviously, if the Earth gets very close to the sun, we'll just fall into it. And it's the same thing with a black hole. If you basically move around the black hole at safe distance, you won't be sucked in. But if you get close enough, and then actually there's a technical word for it, like event horizon. So if you go past that region, you basically fall in the black hole and never come out. And so it's the same with the dark matter, right? So not the dark matter could just be all around the black hole, but the dark matter that comes into the event horizon obviously will go right into it. And because it's matter and it has mass, you add more mass to the black hole, so the black hole just goes bigger and bigger, more massive. So this is how we actually measure, we actually see these gigantic black holes in space. We call these supermassive black holes. They start small. They could start the size of a normal star, or even smaller, like primordial black holes and so on. And they grow bigger by merging either with other black holes or dark matter or stars, planets. You can throw anything in that, so just grow bigger. So I think in principle there could be a neat experiment. I don't know if too many people talk about this. Is like basically how much the dark matter that falls into these black holes powers the growth of these black holes. And there's actually quite a bit of a puzzle, because we see these gigantic black holes very early on in the universe, and we don't actually know how they could have grown so big in such a short time. Now, because you have a lot of dark matter in the universe, that could possibly be an explanation. Maybe not the full reason, but maybe part of the reason is that you basically put a lot of dark matter into these things and just have them grow faster. Yeah, I think.
Is where on the scale, like if you talked about like from a 1 to 10, what is, I mean, is that the strangest thing, is black hole and dark matter, or the two? I mean, they gave them some pretty good names, but are they just, because are they all like a 10 on the scale of things that are just unknown to us, or ways we haven't been able to test yet? Like I'm sure with other stars and planets and things of that sort, they're probably lower on the scale because we're able to know about exoplanets, properties of planets, things that we can actually research into. But dark matter and black holes are kind of two areas, it seems like, that we're still
Yeah,
trying to
there's
figure
a
out.
lot of like strange names in astronomy, and a lot of them are basically just insults or derogatory. I mean, black hole, I think it just came out as a joke of like an astronomer at Caltech, and he didn't believe in. He just used this term, and it kind of got stuck. I think before that they were just called dark stars, which is not nearly as exciting as a black hole. But we also have another term like Big Bang was another joke, that there's this astronomer in Cambridge, Fred Hoyle, who didn't believe in the Big Bang, and he said, basically just, there was an interview at BBC, and he said, "Oh, this Big Bang." But again, the term got stuck. But so there's a lot of things we don't actually understand. There's more things we don't understand than we do, right? So the black holes, Big Bang, dark energy, dark matter. Um,
Well, when it comes to, I would say, a hypothesis or something that you probably lean more towards when it comes to either a theory or idea about dark matter, or you can even talk about black holes. You can get two separate answers if you want. Where do you stand? Because I know you mentioned a couple different theories and ideas out there, but where do you stand on like the idea of dark matter?
Uh, I don't have basically a mainstream idea. I don't know if I have my own theory of what dark matter it is. Obviously, I'm fairly convinced of the evidence of dark matter, because there's lots of observations, at least in the astrophysical realm. Now I'm a bit concerned we have actually seen anything in terms of like, not the lab, but CERN. They have very powerful experiments that they should have been detecting dark matter by now. Also, I was quite hopeful we could see some signatures of that dark matter annihilation. So I think I'm a bit on the sidelines. I don't know. I'm not trying to put a theory out there, or like a preconceived idea what dark matter might be. It is what it is. I don't know. It does some effects. Obviously, as I said, there's another theory called MOND, which doesn't invoke dark matter at all. It's just playing around with the force of gravity. I'm not particularly keen on that, because I think we do understand the force of gravity fairly well, since Newton and so on. And this idea of playing around the force of gravity requires some fine tuning or something. The force of gravity has to change in a specific way to explain for the dark matter. So then you basically back to square one. You have to explain why the force of gravity changes that way and not another way. So I think, the more theories you put out there, the more questions you need to answer.
Do you think with measurements of dark matter, if we're able to finally measure how much dark matter would be around on Earth or just in a general space, we could use that to examine other planets and see if there was a connection with gravity of some sorts? Like we have planets that have other gravitational pulls, or just gravity in general. Another planet could weigh 10 times more, 10 times less. I'm not trying to connect it to. I'm just wondering if there's somehow, like, throughout history, I think sometimes you can get two things that might be the same, but you just label them different things. And instead of being two separate entities, they could just be one. I'm not saying that dark matter is gravity. I'm saying, could it be a possible idea that there could be some type of interaction on the basis of whether it's our atmosphere or something like that, but also we can't perceive dark matter. So how the hell would I be able to know if it did?
uh,
I'm thinking, I'm just
I,
out
th-
there, like at the same
I
time,
think
I'm
you
also thinking
started.
of
I
weapons.
think I'm trying to work with. I think you started with the idea of dark matter being like the size of another planet, or right. That would still be dark matter. Um, I mean, there's a lot of dark objects out there. There could be made of dark matter, as I said. That you have these little clumps extending all the way down to the size of Mars or the sun, right? So you could have dark planets made of not real planets, but you could have a an object which is self-gravitating, detached from the rest of the universe. Is like a little clump of dark matter of the size of another planet. And that would be a dark object, a dark mini halo, right? But you could also have dark stars. There's stars like normal stars, like the sun, but because it's finished up its fuel, it's very faint, it doesn't emit too much light. And to us would be dark just because that we don't have enough powerful telescopes to detect it. Now, these black holes are also dark. So there's lots of dark objects out there in the universe, and we don't actually, we have to understand how many black holes are there, how many dark matter halos are there, and so on, how many dark stars. I think there's fairly good constraints from a bunch of techniques. I mentioned that gravitational lensing technique. So you have like a little clump going in front of the star, it dims the light. So you can actually, just looking at different stars in the galaxy, look at the light curves as well, like how the light evolves with time, and just see these little dips in the light of a star, and just find out how many of these dark objects are out there. Actually, this reminds me, there was an interesting discovery just a few days ago, a few weeks ago, about black holes in the Milky Way, which were discovered with this technique. So there's a telescope called Gaia, which is observing the light from like a billions or so stars in the Milky Way. So we knew about lots of black holes in our galaxy, but it's orbiting other stars, and these were called like X-ray binaries because they're very close to each other, and the black hole sucks up the material from the star, and it just emits this powerful X-rays. But there's about like a couple of hundred or so X-ray binaries they've been discovered, but now we believe there's many more black holes attached to stars, but that are farther apart. So that instead of being sucking material from the other, it's just like fairly stable, like two stars, right? One is dark and one is normal star. Kind of like that Tatooine solar system, right? So you can even have, in principle, a planet or planets around these two stars. One is a dark object, like a black hole, and the other one is a star. Now, what has been discovered we haven't been seeing planets yet, but we see there's a binary system, like two stars. One is a black hole and one is a normal star. And I think the first black hole that was discovered like that was like a few months ago. It's called BH1, stands for black hole number one. And then the black hole number two was discovered like a few weeks ago. And that's basically another black hole orbiting a bigger star. So the first star was like the star like our sun. This second system is basically like a red giant, like a sun that basically in late stages and just like puffs off and it's a big star. So these two stars are basically stable, orbiting around each other. And it turns out that these objects, this binary configurations are much more often, much more common than we thought. So there could be millions of these things out there in the Milky Way, and billions and billions in the universe. So I think it's very interesting. I think in the next few years we're going to have we can count all these objects, and I think it's very fascinating to have like millions of black holes orbiting other stars, and possibly we know that exoplanets are fairly common, right? So we know that basically every star, or most of the stars, have solar systems or planetary systems around them. And not all of them would be habitable, but planetary systems are fairly common around stars. And there's nothing that prevents having planetary systems around this binary configurations. And I think it's really cool. I mean, you could actually be born on a planet where you have a sun and then a black hole, and you orbit both of them.
Isn't there like a danger in that as well too? Like how much information are we losing if a black hole happens to get too close to another solar system or another planetary system and then be able to take away an exoplanet, for instance?
Yeah, I think it's fairly unstable. So our solar system is fairly stable because you have one star to take care of, and then all the planets know how to orbit. But if you put two stars in the mix, basically the planet might go closer to the sun and then closer to another sun or another black hole, and then it just gets disrupted. It's a bit more difficult to have like stable planetary systems. When I say stable, you could still have them orbiting around, but because the orbits will be a bit more chaotic. So for having life, for example, you need more stable orbits because you need like something predictable, seasons and years and so on. But if you have an orbit that goes, for a few million years very close to the sun, and then for another few million years very far away from the sun and so on, you can't sustain life. So I think, yes, there's a danger for just maintaining the right distance from the stars to maintain life. But also if you get very close to a black hole, then there's that danger of getting into the black hole and disappear.
To me, it's interesting. It reminds me of like looking into a machine and seeing all the gears where there's different like cogs that are spinning and everything's kind of just flowing in order, like the belt's just going back and forth. That's kind of like with the universe. Like ours is perfectly, just it's functioning. It's not like nothing bad's going to happen until like sun dies out in whatever billions of years. But then you got other solar systems where it's more chaotic, whether they have another influence, whether it's another star or something of that sort, which makes me wonder why our universe is just so specific. I get the one star argument, but I mean, is it just luck and just how society, or maybe how we're viewing it, because the fact that we can survive in the solar system that we're in without any problems? But it seems like everything's like strategically placed. I'm not hinting at a creator at all. I'm just saying it's just like that's a weird chance, which makes me wonder if there could have been possible better scenarios, or if it could have been worse scenarios.
Yeah, well, actually, there's it's actually a question that scientists ask. It comes down to the fine-tuning argument. And I think that was an argument, that's an idea that was put up in the 70s. And the idea is that, well, if you look at, for example, constants of nature, the force of gravity, as I said before, if you basically put more dark matter, but you could also change a bit the force of like the gravitational constant that goes into Newton's force, make it, instead of 9.8, whatever the number is, you can make it 12 or 25 or so on, or whatever, 5. So you play a bit with the strength of the force of gravity. You basically could grow galaxies faster or slower, right? And then again, is a timing argument. Or maybe if the force of gravity is much much weaker, you don't actually form any galaxies or any stars. Everything will be a bit of a mess. Or if the force of gravity would be much stronger, everything collapses, the stars will blow up very fast, there's no time to form life, and so on. So that's just the gravitational constant, but there's like about 30 fundamental constants that come up from like different theories. Like electromagnetism also has a bunch of constants, like the strength of the electromagnetic force, how strong is the electron, for example, bound to a proton, and so on. So if you play around with this fundamental constants, you also mess up with the force of electromagnetism. So then there's another way that you can mess up with the formation of life. As it turns out, there's about 30 or so fundamental constants which are all fine-tuned for life. This is the idea is like, well, how does the universe know how to come up with this particular constants of this particular values, right? And these constants are, not necessarily between 1 and 10. They some could be very big and some could be very small. So it comes down to this question of like, well, I don't know, maybe you can form many, many universes, but not all of them will have life. And the fact that we live in a universe that has all these constants ready for life, then basically we're here to observe it, right? So it's called like the observer effect or something like that, like a selection effect. You're in a universe that you can observe. If the universe would be not good for life, you wouldn't be there to see it. So in principle, there could be many more universes out there. It's like the multiverse theory. Now, I think recently, so that's that. I mean, I teach these things, and there's like books on it, and there's like a whole argument of fine tuning. This is kind of a classic thing, but I think recently, past few years, people are saying that, well, in principle, I mean, it's not. The word fine tuning is a bit of a extreme case because people have went back to theory and tried to say, okay, you say this and it makes sense, but what actually, if you actually go and do it, change the force of gravity by 2 orders of magnitude, or change the electromagnetic force by, just change all these constants a bit up and down, just dialing the dials a bit up and down, and see which universe will form life. And it turns out that there's a margin of error. There's quite a few universes out there which could form life. Doesn't have to be exactly ours, right? Now, there's still like a big problem because like the number of universes which are not good for life is much, much bigger than the number of universes that could have life, right? So again, it comes up to, okay, what's so special about this particular universes than the other? But it looks like the problem is less stringent as it was before. It's not really a fine tuning. It's just like, well, an interesting bit. Yeah.
Do you find that the split between scientists it divides into two parties where it's kind of like the risk reward factor? I mean, what do you gain from being able to do something like this, but at the same time, what are you risking as well too? I mean, fine tuning, I would probably use a different word choice for it because it just sounds like it would be triggering to a lot of people that would be like, what are you saying? This universe doesn't have anything good to offer? It's like, I'm not saying that at all, but I'm saying what it's the possible scenarios that we could make it or improve it. And then that becomes into the argument of like, what happens if you try to improve it and then end up doing something dangerous? So is there a risk reward factor in the areas of research that you study into? And I think there's plenty of movies about tropes of people that try to do something research wise. It's a little bit fringe and ends up destroying like a whole planet or something like that on accident, which I think is probably largely just misconstrued. I think that's just good for a movie plot. But when you're exploring things and you're trying to test out things, I mean, there's been worst ideas in history that have been tossed out before. Trying to launch a nuclear missile at the sun, not sun, the moon was a plan a long time ago that they wanted to do just to test their power to Russia. And it's like, oh, you don't realize it could affect waves and it could affect so much stuff, if you will, of the moon. So there's constantly theories that get tossed out there that sound a little bit insane, but the fine tuning the universe one, I don't know. To me, it just seems like something where like we got lucky. And if this is what we consider lucky, I think is because we've adapted to grow this way because of the way that the universe is lined up. So maybe a certain change that we would think would be the benefit could actually probably hurt us even more. There's it's not I guess an exact science. And I mean also at the same time the argument could be what impact would we have on the universe that could change the whole universe? I don't know. I don't think we really have the tools to be able to affect it, the whole universe so much. I think the worst we can probably do is blow up the moon or blow up Pluto. But other planets, I feel like they were just a little bit too big for our technology.
Yeah, I don't know if we can affect the universe. Obviously, there's this thing from quantum mechanics that tells us that you actually change the universe as you observe it, but not doesn't go in the way that you were describing of basically affecting the whole expansion of the universe or the stability of planets and so on. I think we could, in principle, mess around with the planets. If we know now we know how to deflect asteroids. So in principle, an evil person out there could, throw an asteroid towards the Earth and just kill life. But obviously most of the effort, or all the effort, hopefully now, is the other way around. It's just how to deflect asteroids from coming into Earth in the first place. Now, obviously, you can throw things into the sun. We do that all the time when we have probes that go very close to the sun. We just let them fall in. But it doesn't make any difference in terms of the sun is very big, so it won't make a difference. We can't affect anything on the scales of bigger than the solar system and so on. Now, to come back to the argument of fine tuning, there's also a interesting thing. And if you look at how old our universe is, like 14 billion years, and it turns out they can't actually form life very early on, like near the Big Bang, because everything was so hot and planets haven't formed and so on. And you won't be able to form life much later into the life of a universe. Let's say the universe expands forever, just because there's not much matter to attract and form planets and suns and so on. And so basically the universe will just die out. So we're actually living in a good time that we can, the life doesn't occur for the entire duration of the universe. Most of if you actually run the clock much further, most of the life of the universe in the future would be without life, because the universe just keeps expanding. All the stars will explode. You're going to maybe end up with some black holes. Maybe the black holes also will evaporate given in time. So everything will just return to a big smoothness of nothingness.
Do you think that everything that could be discoverable is already created, or do you think there's still things out there that are left to be created? Now, there's things out there that we are finding out that exist that we didn't know existed before. That's a different discussion. The discussion I'm saying is that things that could be potentially created, even though we don't have the technology to perceive it yet. I start wondering, I'm like, I feel like everything's that's going to exist is already existing, besides human influence stuff. I mean, just like space wise, things that are out there in the solar system already. I just feel like we don't have the technology to discover certain things.
Create what? Other matter or
Anything like discovering a white hole or discovering things of this sort. Like we know concepts about things, and it's not like those
yeah.
things don't
Well,
exist.
discovering is a bit different from creating. Obviously, we haven't discovered everything there is in the universe. And we discover things all the time. Creating, I mean, you could create artificial stuff, like in those sci-fi movies. You could just create, let's say in the future, future humans might want to move out of the earth, just
Why?
because
It's perfect.
well, in case you want to move out, you have to create something. You either move up on another planet, but because the planets are very far apart, the next star is Proxima Centauri, is about 4.3 light years away. So it takes light about 4 years just to travel there, and us will take much more time there because we don't travel with the speed of light. So basically moving from planet to an exoplanet is very impractical. So you have to find a way of creating habitats that are not necessarily associated with exoplanets. So you could, people are imagining all kinds of alien technologies or artificial technologies that will basically harness energy. You need actually a source of energy. Like we have, life needs the energy from the sun. But in principle, you can harness energy from other things as well. You can even harness energy from a black hole. If you just know how to, if it's a rotating black hole, you can just extract a bit of energy from there. Yeah, if you have. So I think but all this, obviously we are creators. We create a lot of stuff on Earth, and in principle, you could create other artificial things.
Well, I
You
meant
could
exemption
terraform.
of us, like not us creating things, but everything in the universe that's already created, human aside. But I mean, like Big Bang created, like primordial black holes, things that we obviously don't have the materials to be able to create. I feel like if the universe, I feel like a lot of everything's already been created that the universe is going to create. And we kind of can only do things to add to that or be able to manipulate to maybe make something new, but then that would be human influenced. But I just feel like a lot of things that we're discovering, like new things, like we discovered this exists or we discovered this exists. It's not like it hadn't had been there before, and there's probably countless other ones that we just can't be able to find. But I feel like the universe after that Big Bang and what exceeded out, that these things have just they exist. and it's just like it happened at one point. It's not like constantly there's just new stuff happening. Or do you think that there's new stuff being created by the universe all the time?
Yeah, there's new stuff, but it's can I mean, there's different categories of creating things. The stuff that was created at the Big Bang came out of nothing. And we don't, it may or may not link to, obviously some people say there's a creator, but we don't actually know what created our universe. The universe was created with a bunch of stuff like dark matter, dark energy, normal matter, and so on. And this stuff is basically always transforming. Like our bodies are made of particles which were in the past part of other stars or so on. And here on Earth, we create other particles all the time at CERN, right? You just bump a proton, like I'm making stuff up, but you bump two particles, you destroy them, you create a zoo of other particles at CERN. So we create, the universe does all the time, like in the center of the stars, you have nuclear reactions, so you can always create new particles and so on. So I think comes down to a concept of what we call conservation of energy. So everything you could transform one thing to another, but always transforming energy. Now, creating a whole new universe requires that energy in the first place, right? So what created our universe in the first place? That's a big question. So I don't think the scientists have that answer yet. Does it make sense?
Yeah, but do you ever think we'll have the capabilities of being able to create universes? Do you ever think we'll have the ability to really manipulate planets like we're able to do? I mean, I feel like our biggest, and I'm not a pessimist, where I would say I'm a little bit pessimistic on just people's personalities at times. I think I'm more of a pessimist on the aspect of I feel like our inevitable kind of doom would be kind of like a historical thing of where we've always looked into something and our curiosity has kind of gotten the best of us in a sense. Not saying science is bad in any sense. I'm just saying we end up using either the wrong materials. We go to another planet trying to use another type of thing that we used before in the past because we know it works, when necessarily I don't think that would be the example. If we went to like a whole nother planet, I would feel like someone would try and look for certain materials that would relate to what they know would be flammable, and it might not be the same instance. You might have to adapt to a whole new type of survival, a whole new template of humankind, basically, in civilization.
Yeah, I'm not sure whether scientists agree
It's a
whether
dumb
this.
question.
So
You can say
no,
it.
no, no, no. I mean, there's a thing that there's a lot of that this multiverse theory is a genuine theory, and it comes up from many types of arguments. And I think I mentioned, well, let me back up. So there's the multiverse could be a thing. So there's multiple universes out there. We don't have any evidence. So again, it comes down to the part of like, okay, there's a nice theory, but there's no observation of it. And it comes that I'm going to come in a second back to some possible evidence for this two universes colliding with each other. But let me say how the scientists actually think there's this theory of multiverse. So this fine-tuning theory or argument that I said earlier, like why is our universe so special? And then to come out of that, well, you can either assume a creator, but scientists don't necessarily want to go that route because they want to explain everything without a creator. So they basically say, okay, if you create an infinity of universes, like, you created our universe, but you could create other universes just as easily, right? You create it once, maybe you create more than once. But every time you basically roll the dice and these constants come up with different values. So basically the multiverse theory is not necessarily a testable thing, but it explains neatly why we live in a universe that is prone for life. Now, there's another idea that comes from quantum mechanics. I don't know if you heard about the Schrodinger's cat. Yeah, okay. So this experiment. So quantum mechanics is very weird because sometimes
It's
things could
that
be
and
particles.
sociology that I the two topics I've only talked about once on the show, and I'll probably never talk about again because my brain can't understand it. Like social economics a
Yeah,
little bit, my brain just can't get that.
yeah, yeah. No one can understand quantum mechanics, or at least I don't know. I don't trust when they say they do. Well, I just certainly don't understand it. So There's a bunch of like weird stuff happening in quantum mechanics, and one of them is that you can never know for sure that we cannot say for sure where the position of an object is, or its speed, or whether that object even exists or not. So I'm gonna say in a minute what it is, but basically you can pinpoint with precision the energy or the time of an event, or the position and the velocity and so on. So, you can imagine this experiment. So this is a true thing. It's not necessarily linked with the fact that we don't have the right measurement tools, right? If you ever increase the accuracy of your, speedometer or whatever, you could actually measure the speed, more precisely. No, if you measure the speed very precisely with 100% accuracy, you can't say where that object is in space. If you measure where it is, you can't say how fast it moves and so on. So there's also another thing going from with like a uncertainty between the energy of an object or an event and the time where you measure. So there's this experiment, you put a cat, right? So if that's the case with like microscopic particles, you could in principle think that, okay, so this may also be the case with macroscopic objects like a cat. So you put a cat into a box, and then in that box, you have this radioactive element, like something that emits radioactive radiation. And then you cannot know for sure whether that atom disintegrated or not. Okay, well, you can actually observe it, and that comes out to that observer effect. If you actually look at it, you can say whether it was disintegrated or not. Okay, so that's another weird stuff that happens in quantum mechanics, because if you observe it, you kind of change the experiment. Right? You can't actually detach the experiment from your own observation of it. So you basically close the box, put the cat in, you don't actually look at it. So there's two options that if that atom disintegrates or nucleus, it kills the cat. That if you have a gun associated with tied it to that atom, you construct it such a way that if that atom disintegrates, it just shoots a bullet into a cat and kills it. If it doesn't, the cat is alive, right? So there's two options: the cat is alive or dead. But that's not true, because the quantum mechanics tells you that you can't say for sure, and it's true that these things could have be equally probable.
It's the damn movie,
but then
The Secret Life of Pets, where they talk about what do your pets do when they're not home. I don't know if my pet's running around and talking and speaking and all this, but you also can't look to find out if you have to go to work. It's like,
exactly, yeah. So once you come home, you actually see what the pet is doing. So if you open the box, you can see the cat is either alive or dead. But the thing is that once you keep the box closed, the cat could be both alive and dead, if it makes any sense. It doesn't, right?
it's wishful thinking. That's
yes.
all it is.
So, I mean, that's why this thought experiment is such a way that you can't have both of them. The cat is either alive or dead, right? But to get out of this puzzle, people will say, okay, what if the cat is alive what if you split when that atom disintegrates, you have the universe splitting in two universes, and in one universe the cat is alive and the other one is dead. So when you open the box, you're basically in that universe where the cat is either alive or dead. So there's no contradiction between what you observe and your reality, right? But basically you split the universes, so you create all kinds of universes out there with like weird, you just like bifurcate you have a highway and you have to go right or left. You can go both right and left in different universes. So that's basically it's a roundabout way of saying that there's another argument for why multiverses exist, because you can create universes out of nowhere just by every time there's something going on, an atom splitting or any event in the universe, you basically create all kinds of universes, and they all exist in the same time. I
never
forgot
realized
where I started from. Yeah,
I never realized that, but you explaining that. But I had a guy on here, John Joe McFadden, I think his name is, and he was talking about quantum mechanics and all this type of stuff. And I realize now, after you explain that, the question I asked was probably the dumbest question to ask him. But I asked him, like, don't you think it's bad? Because we talked about the multiverse. And I said, don't you think it's bad if you ever met yourself? Like, it's like trying to understand reality. Like, our realities in our head are pretty sensitive. But if you ever came in contact with another reality into your own reality, then it becomes like the argument of trying to understand oneself. And it's not like a deep philosophical question. It's more about like if I try and analyze the particles in my hand and realize that there's particles in my hand that somehow are moving at a speed that this particles in this table are moving at a different speed, but yet my hand cannot go through it. Doesn't make sense. And you ever end up analyzing it too much where you get put into like a mental institution. And he just kind of stared at me. I was like, I might have been a dumb question. I mean, it sounded like it made a lot of sense, but I start going. I mean, it's the same thing with you're trying to understand your own reality as well, too. I mean, if two realities or two universes do come in contact and those two universes have similar like properties, but also are different, then wouldn't that cause like an incursion? Wouldn't that cause some type of warp in reality as well, too? Which I'm a little bit more interested in tearing the reality, like the fabric of reality, which I think in our own minds, it's pretty sensitive. You can probably do it very easily. But when it comes into over analyzing something so much to the point where you can actually shatter your own reality, which can possibly change the reality that we're in, I know that's definitely a fringe and kind of way out there idea or just
No,
understanding.
I mean, obviously there's movies about this and books. Once you create universes, you don't stop. So basically, there's going to be multiple versions of you in every second or every,
Somebody better own a
you know,
Lexus. I know that.
whenever you make a decision to go right on the highway, you also make a decision. I'm just kidding, but anyway, there's multiple. If you believe in that theory that you can create universes at will and basically have no choice but to create universes every time there's something going on, there's an infinite versions of you, right? So and
That's how I justify people in a coma. I go, they're making multiple realities right now that we can't perceive.
yeah, I don't actually like that idea because it's based not very economical. Sorry, not what you just said. I was still thinking about that, what I just said. So if you create multiple universes, again, it's kind of like not a very economical way of explaining stuff. In order to explain a small problem, why is this constant 9.8 and not 10? You just create an infinity of universes, right? Why, or instead of saying, well, I don't understand quantum mechanics, I'll just say I'll create an infinity of universes and that will basically explain my reality. So I just don't like the idea that everything could happen for no reason, and there's an infinity. You just create too many things
Well,
and still doesn't
it's
explain.
a being contrarian to science, I would say. I mean, if you're trying to categorize and define, it's like some person that goes to explore every aspect of an island and make a map about it. Okay, well, if I tell you that your island actually is part of this island over here, then I just keep increasing your work process to the point where you'll never be able to fully discover all of the island like you wanted to do. Which sucks because it's like I think there's a lot of people like that out there that really don't want to lose an argument at times either, and kind of want to base. You can call it wishful thinking, you can call it hope, but there's also like at some points we have to start defining what reality is and be able to go by the terms. It's all of what society does. We have laws for a reason. We all agree on certain laws. Killing is bad, these types of things. There are people that try and break those laws and they get punished for it, but there's an overall accepted by the public mind that this is the reality. You can have your own, but this is also the reality we all agree upon, where you can't mess with these basic constitutions or these pillars of old, I would say. And then you get into science where there's a lot of fringe stuff out there too, which I think is interesting to listen to. I like fringe theories and things. But then it's like, why, if you accept one and then you don't accept the other, I just go, it's kind of like a double standard. Like just because you like this one better, even though we all haven't agreed on both of them yet, but because you like one over the other, then you will go with that one and say it's correct. Well, I go, well, hold on a second. What's the overall poll that agrees that this is the concept we'll go into? And then you get the hypothetical physics and a bunch of other stuff where I'm just like, oh my God, I need a muffin or something. Holy crap. Like that's a lot of work.
Yeah, well, nothing says that the reality that we can test with our experiments is the reality. I mean, it's basically just the confines of whatever we can measure. So scientists like to stay safe within the stuff they could test, and I think that's a good approach because obviously you can think of lots of realities, but if you never can test them, You can never test your ideas. Like you say, there's two versions of you, but if you can never find that out with any testable experiment, that is, that's a nice idea, but how
The
do you
multiverse
measure
theory
that?
is a good one to like, kind of look at, like talk about, but it's not one that I would put any weight into it actually existing because the fact that we have no evidence to really support it. We have hypothetical ideas of how they could exist, but I wouldn't put weight into it. I mean, it's interesting to talk about like multiple things, but I mean, I'm also a guy that says that we faked the moon landing, so we're just gonna say that out front. But no, like there's real things I try and base a lot of
Yeah,
things in
by the
evidence.
way, today they're releasing the names of these astronauts who are going to go back to moon. Well, at least not land it, but just orbit around the moon.
For the first time.
Um,
Just
yeah,
kidding.
cool. Yeah, well, I think there is a way of testing it. I mean, so there's the idea of multiverses from different theories that they don't necessarily mean the same thing, Um, I like the idea of like, okay, well, because we can't explain the Big Bang, right? You have to create the universe out of nowhere. But there's another theory there calling inflationary theory. So basically, you create it from a small virtual particle and it just blow it up and you form a universe. So if that's the process that works for our universe, because you have this, nothing stops. You have virtual particles everywhere, so you could form another universe over there and another universe over there, and they won't necessarily interact. You can have them all existing in the same time or space, but well, not in like on top of each other, but they could exist in the same time, if it makes any sense. Again, this is not necessarily observable in the sense that you are confined to one universe and the other universe is separated. Now, in principle, this universes could collide, like these bubbles, like you have these soap bubbles in the air, and then some of the two bubbles would collide. And that could be actually testable if you have two universes colliding. They might leave some signatures in our universe. They have, like, say, if you're a universe, a physical, I'm talking about physical, I'm not talking any like extra dimensional things. I'm talking two universes, right? Close with each other, bumping into each other. And that could have an observable effect. I talked about this cosmic microwave radiation, like this heat that's left over from the Big Bang. Now, this heat is not necessarily exactly the same temperature. There's little fluctuations up and down, like some cold spots and some hot spots, right? Now, if you have another universe colliding, just create a bit more like a hotter bump or a colder spot, So basically, like a call a bruise on our universe. So you can actually see these signatures in principle into the nice map that Haystack was showing, right? You can actually look for these bumps, which are genuine part of our universes. But if you have an extra bump there and another pump which is a little bit hotter, colder, or doesn't make any sense in the context of our universe, might come from a collision with another universe. So I think people have proposed that and looked for it, like genuine scientists looking for it into, and I haven't actually seen anything like this yet with the data that we have, but it's not inconceivable that that's a nice experiment that you have the theory of the universe, but you can actually think of an experiment or some type of measurement that could, in principle, measure that interaction between two universes. Now, having said that, the universes that create during quantum mechanics, that argument that you can, at any given moment, you create separate universes, those don't interact with each other. So, that the dead cat and the live cat will never meet, at least in theory, in quantum mechanics. Now, I don't know enough about it to know why. I suspect it's something to do with the paradoxes that scientists don't like, like having two versions of the same person meeting or things like that. But I don't think it's anything, I don't know enough about it, but I suspect it's something to do with paradoxes that people try to avoid rather than like a clear no from the theory. But my impression is that this multiverses that can pop up from quantum mechanics, they don't interact with each other.
I don't have a whole lot of things I fight the fight on. Like I won't stand in the way of anybody that wants to explore that hypothesis for sure. I just before I go and start running with it and joining the side of it, I want to know if there's more conclusive evidence of it. Like, because then I could just pull out the overanalyzation qualities of like doppelgangers being multiple personalities or universes of the same person on one plane of existence. Like someone that looks similar to me could be a multiversal character theory, not exactly me, but just from a different perspective. If you look at, that makes a lot of sense. Once you really start sales pitching it in a certain way, you can really make it go any way like that. That just makes it more difficult, which I think is why the whole point of like having these conversations is important, because then you get to kind of learn and get people's ideas on things. I'm sure I've heard many theories from Haystick that I necessarily don't agree with, that he thinks are interesting just to talk about, but he's also not going to fight the same fight on if those things are existent or not. And they're more like fringe stuff. He's a big sci-fi guy like me. I like some sci-fi discussions, more about planetary civilizations and stuff like that. But if you ask where we would put funding into, I mean, I would talk about the whole planetary defense system, instead of probably exploring if there were multiverse theories out there. I just don't feel as good as this universe is. We talk about the fine tuning aspects of things. It's also really sensitive in the fact that we have made it this long. And I know there's other things like gravity and there's asteroids that can just miss us all the time, and we haven't gotten hit yet. But it's that possibility of like, that's the yet factor. I mean, we've gone this long of time without something happening. What happens if it could be, are we ripe? Is it that time for something to happen? I have no clue. But to me, that's more of an interest of an area as well, too, as much as it is exploring out there. Because I would like to get on another planet at some point in my lifetime. Would be pretty amazing. I doubt it's going to happen, at least me getting to another planet. But just being able to step onto another planet or be able to pull out maybe a civilization or do something in a short amount of time, because we do make long periods where we try and discover something. And then once we discover something, we end up cutting that time in like 1/4 the time it took us to be able to discover it. Like our time of technology from like the very first creation of like the radio to the phone might seem like a long time, but then from the phone to like what we're at now, very short periods of time of just constantly excelling. It's like once we get used to the technology, we just keep expanding at an even faster and faster rate. So getting onto a planet might take a long time, but then once we get one down, I'm sure it'll be quicker and quicker and quicker and quicker the next time, as long as we keep colonizing other planets. That makes
Yeah,
sense.
it's definitely, yeah. No, I think there's the fast pace of discovery. If you think about the normal science, like uh
I want to be the first man on the moon. That's what I want to be.
you won't be. Someone already went there in the 70s or 69. Yeah.
Allegedly. I'm
Yeah.
kidding. I'm kidding.
Yeah, I mean, the science is kind of like the hard science is kind of a new thing. Obviously, people have thought about the universe in different contexts, and it's by no means the only way to think about the universe, like the science we have. And in the future, that could be a different science. I mean, there's different big gaps in our understanding. We don't know, like we said, dark matter, dark energy, and so on. We don't know what created the Big Bang. We talk about realities that ties it with the consciousness, right? We don't actually know what consciousness is. Whether that ties in. I mean, obviously, reality. It's easy to believe in your own reality or fool yourself that this is the reality and so on. But how do you actually test it? So there's, we don't actually know how the brain functions. We haven't cured cancer and so on. So I think there's a lot of things that will hopefully happen, and hopefully will happen faster and faster. I think once we understand what dark matter is and so on, or even if we understand, even if we understand one of these things, I think will be amazing. But I'm sure we will, given that the pace that the humans are evolving.
I put a
Yeah.
lot of weight in future people. I feel like we can, as much as it might seem impossible now, I'm always thinking like next 5 years we'll have it all figured out or something like that. It's not, I don't go like, oh, that doesn't mean we should take action now. We definitely should, but when it comes to certain possibilities, I'm like, there's always someone that just randomly in the middle of the night, like Da Vinci's a hero of mine, just because if you read like some of his journals and some of the historians that talk about a lot of his work and stuff like that, a lot of his late night creations, just a spur of inspiration. I put so much weight into that. I know it's like not something you want to bank on, that you don't want to bet the farm on it, but to me it's just interesting because there's always something tomorrow where someone goes, I have this idea. The next thing you know, we try it and it ends up changing either the way we think about things.
Yeah. Well, yeah. is a good one. I think it also comes into obviously Da Vinci was way above normal intellect and so on, or consciousness. So I think it's even, I don't know whether that's even if you look at people's abilities, there's a wide range, like playing music or so on, or writing poetry. There's like some people who can do it very easily and it comes natural to them, and some people we can't. So I think in terms of Da Vinci, obviously he came up with a lot of ideas that were way ahead of its time.
A tank that
And
shot from all sides is probably his best invention besides the flying machine.
I didn't know that.
It was a
Like in the
circular
battle.
it was a circular tank and it had cannons at every single point so it could fire from all around and it spun on a gyro. So you could spin it as you moved it, it would move in a circular position. So instead of going forward and back and forward and back and trying to do like a 20-point turn, this thing could just the tracks would rotate. So then you could spin around as much as you want in circles and also be able to fire from every aspect so no one can sneak up
Right.
behind you or from the sides of you.
Yeah. So did they actually use that? I know he was hired by some lord in somewhere in Italy to, I think he ran out of money and he went, got hired by someone, and he did work on some military stuff for a while.
I think he created a prototype. I know there's a museum out there that has one of it, but I don't know if they created that later. It can't be the same exact one because I'm pretty sure all of his inventions were destroyed.
Okay. Yeah.
He also had a
I
weird
heard there's
idea with
some,
his proteges. He would have a new protege every couple of years. And I was like, what is that about? And I guess he didn't want to be connected to, he wanted to like pass on his knowledge, but at the same time not be invested into one protege, which is interesting because we don't really take that method now. We like to connect with someone, then keep that person for as long as we can.
yeah. Well, nowadays they're called PhD students, so you only have them for a few years and then just kick them out. Or students. Yeah, it maybe he didn't want his ideas and someone to steal his ideas. Although I think he was so far ahead, it probably would have the other way around. It'd be hard to explain his ideas to people. Um, yeah, I mean, it's hard when you're at that level to kind of share your ideas. And I think, is that true that some of his notebooks are still undiscovered or got lost?
They
Seem
just
to.
discovered recently that there was a painting that someone had painted over that was actually originally a Leonardo da Vinci painting. Someone had found a painting of his that was very rough, and he was known. I think he might have had ADHD because there's a thing with ADHD where you start a lot of projects but you can never finish one. And that's like a big problem I have. I end up doing like 50 things and never able to finish one. He was known as like the unfinished artist because he always thought you could add something to something to finish it, which makes you a great perfectionist, but it also becomes a problem when you're trying to create things. Now, he created a painting, and what he would do is he would rip a lot of his scrap stuff off and then throw it away. And someone had found like a half finished thing of his and then decided to finish it. And it did look pretty exact. So it's like easy to copy something if you're pretty skilled in doing so. And then someone over years and years and years had painted over it and over and over and over. And then they finally found all the way under all these layers of paint that there's an original Leonardo da Vinci basically sketch. And then it got valued for like, I don't know, an insane amount of money, which is just like, I would love to see his notes. I mean, there's diaries and journals that he probably kept that no one
I,
knows whether they were burned
I
or
think
whether
that
they're hidden.
I think they recently digitized all his notebooks, the ones they survived, and I think they're somewhere on the internet. I think they're um, quite fascinating to look
I'm
at.
about to do me a deep dive. That's a big
Yeah,
area. I didn't know
yeah,
about that. Him and Galileo were like two for me, where it's just like, I don't know. I'm a big fan of like rejects of society. As much as Leonardo da Vinci gets a lot of praise, he was not necessarily accepted for a lot of the things that he was talking about either. He was kind of seen as a little bit crazy. Which to me is just like if I could go back in time, I wouldn't even worry about the JFK stuff. I'd just go straight back to Leonardo da Vinci and find those guys. Because that thought process has to be insane. I mean, imagine being in a room with like Albert Einstein or someone like that, just to be able to get their processes on things, at least how they were thinking at the time. I mean, like I said, I'm a big underdog person, so
yeah. Well, they've done mistakes as well. They were not perfect. I mean, Galileo, it's a bit. I have mixed feelings about him, right? Because he had a bit of a temper and so on. And Einstein, he obviously did some mistakes. Well, obviously everything was, his mistakes were much better than our best theories. But for example, he didn't quite believe the universe was expanding. He was trying to tweak his equations to make it static. But it turns out that his equations don't like to be static. So basically, there was a clear prediction from his equations that the universe would, if you know, basically there's a predictions in his equations for a big bang, for the beginning, right? An expansion of the universe. One way, or it could be that these equations could be worked backwards as well, so the universe would contract. But either way, the universe is not stable. But he didn't quite like the idea. He just wanted a perfect universe that's always the same, you know, doesn't do anything out of the ordinary. So he put this fudge factor, like a constant, in his equation, was called the lambda constant. And later on, when they discovered the universe was expanding, he said, "Oh, that was the biggest blunder, the biggest mistake in my life." But now we like this constant, because this constant, if you put it back into his equations, is basically just similar to, looks like the dark energy. So he's basically pushing his universe was contracting, so he was trying to put this constant to make it static, right? So like they'll push it backwards, so then you have neither contraction nor expansion. Now we know the universe is expanding, but if you put this constant back in, it's basically expanding faster. So this is the dark energy, which again, we don't know what it is, but if you just put a constant into Einstein's equations, it just expands faster. They were not, I mean, they were like, you know, they were not always smart. Obviously, Einstein had like pretty poor choices in his personal life, but they had these spikes of creativity and these great ideas. And, you know, if you have one or two during your scientific life, that's you're set.
That's like I said, I necessarily don't have to agree with these people, but at the same time, I'm interested in the creative process. You know, like what people that were going through something. That's why I never dismiss anything. Like I won't I need evidence for some things to get on board with, but I'm not going to stand in anybody's process or doing anything like that of saying like, no, we're going to ban you, we're going to doing this. If they're right, they're right. You know, I mean, worst comes to worst, at least you didn't stand against them. So when they do end up, you know, if something happens and you know you're on the still the friend side of things. I don't know. I'm open to a lot of theories that necessarily I probably shouldn't be, but that's my fault. But Andrea, I appreciate the time you gave me to talk on my show. Is there a place where people can find any of your links?
They could find me on. So I work at Astrophysics Research Institute at Liverpool John Moores University. So if they go there, they could find my staff profile page. That's about it. Contact me
Twitter?
on social media. Twitter, yes.
Instagram?
No, not
Okay.
yet.
All right. Get on Instagram. I'll follow you.
Okay.
But I'll link all your links in the description. It's been a pleasure chatting with you. And thanks everybody for listening to this episode of Out of the Blank.